Alright, so let's end the section with a modeling example. So let's consider brine tanks, which means tanks with water and salt in them. So in chapter 1, we considered these tanks, but usually we only consider one single tank and how much salt is in it. But now we're going to have multiple tanks and having liquids flowing between each other. So let's have a smaller tank with 100 gallons of water and a larger tank with 200 gallons of water. Okay, so there's going to be a lot of pipes and liquid going in all different directions. So fresh water is coming into the first tank at the rate of 20 gallons per minute. And the mixed liquid in the second tank is leaving at the rate of 20 gallons per minute. Now, between two tanks, liquid is going back and forth, so there's a pipe going that way. Let me draw the arrows for all the liquid directions. So the green pipe is going from the smaller tank to larger tank at the rate of 30 gallons per minute. And this is, yeah, so the mixed brine is going that way at the rate of 30 gallons per minute. And there's another pipe. Now, mixed brine in the second tank is going into the first tank at a rate of 10 gallons per minute. So, first thing to notice here is that there's always 100 gallon liquid in the first tank and 200 gallon of liquid in tank 2. If you calculate it in and out, the amount of liquid stays the same. So no tank gets dried out or no tank gets overfilled. First tank always has 100 gallons of liquid. The second tank always has 200 gallon water liquid. So that X of T be the amount of salt in the first tank, and Y of T be the amount of salt in the second tank. Then we can use a similar method from chapter 1 to form differential equations between x and y. So x prime and y prime. So let's see what happens. So x prime is the amount of salt, change of amount of salt in the first tank. First, fresh water is coming at the rate of 20 gallons per minute, but it's fresh water, so it doesn't really contribute to anything. So it's 0 times 20 gallons per minute. Technically, 0 gram per gallon times 20 gallons per minute. That doesn't change anything because it's just water coming in. Now the green pipe takes away 30 gallons per minute liquid away, and the concentration of tank 1 at that moment is X over 100 gram per gallon. So because it's leaving tank 1, so this is subtraction. But on the other hand, liquid from tank 2 is coming into tank 1. The salt concentration in tank 2 is Y over 200. The unit is gram per gallon. And it's coming in at a rate of 10 gallons per minute. Alright, so that's the first equation. Second equation is similar. Y prime is the change of amount of salt in the second tank. The red pipe takes liquid away, so at a rate of 20 gallons per minute, with the concentration is Y over 200 grams per gallon. And this is negative because liquid is leaving. And the green pipe brings salt in, and the secret is however much is leaving the first, however much salt is leaving the first tank is however much salt is coming into the second tank. So you can just copy down the terms from above. And the same thing, however much salt going through the purple tank into the through the purple pipe into the first tank is however much salt that's leaving the second tank. So this is minus the purple term, 200 times 10 gallon per minute. So the finalized equation is x prime equal to, the blue term is 0. Let's see, negative 0.3 x plus 0.05 y, and y prime is equal to 0.30. Yes, the red term is negative 0.1 y plus 0.3 x minus 0.05 y, which is equal to, this can be simplified, so this gives you x prime is negative 3.3 x plus 0.05 y. This is y prime equals to 0.3 x minus 0.15 y. Alright, so in the next section, we're going to learn how to use diagonalization to solve differential equations like this. Right.